Okay, so now we begin our last unit of the semester, and this is going to be Chapter 5, or Unit 4. We'll be studying financial information. This is perhaps the most relevant and most useful section you'll ever take here at college. Stuff you'll definitely be using very soon in your life, shortly after graduating, if not before, if not already. So we'll be looking at loans, saving money, and we'll progress to where we're depositing money while working to save up for retirement, pulling out money after we've retired, paying off loans with monthly payments or weekly payments or annual payments, and etc. We're going to start our study in the financial world with simple interest and compound interest before we progress to looking at making regular payments, whether we're depositing or withdrawing regularly. So we're going to start with simple interest here in 5.1. Some terminology and formulas that we will be using for simple interest. And I will go ahead and let you know all the formulas that we work on and use in this section will be provided to you come test time, or you'll be able to write them out on a sheet of paper and have that with you when you take your test. Okay? So, some definitions. The amount of money you deposit, or if we're borrowing money, the amount of money we borrow is called the principal or the present value, and its variable is going to be a capital P. Okay, so the amount you borrow or the amount you deposit at the very beginning is called the principal or the present value. Simple interest is when the interest amount is periodically given back to the investor instead of being reinvested. I am assuming we all know what interest is. If you do not know what interest is, please schedule an appointment to talk to me so we can discuss exactly what interest is. Okay? So simple interest gets mailed to the owner of the account, basically. Instead of being reinvested into the account, it gets mailed to the owner, and the owner can do with it what they want. So, our formula for simple interest, the simple interest on an investment or loan of P dollars at an annual interest rate of R, and note this is in the decimal form, for T years, T is our time in years, is given by this formula. Interest equals the principal times the rate times the time. The rate is in decimal form, the time is in years. Those are very important details. The future value, or the accumulated amount, which will that be A, of an investment or of a loan of P dollars, is given by the future amount is the principal plus the interest. So we can kind of think of that as P plus PRT. And since P is a common factor of both terms, we can factor it out, giving us the formula A equals P times 1 plus RT. Okay. We can also calculate interest as A minus P, but we do need to know the future amount and we do need to know the principal in order to use this formula. We do have two very good, useful formulas for simple interest. One dealing with calculating just the interest, one dealing with calculating the accumulated amount. Okay. You need to be able to solve for any of these variables in either of these equations. Okay. Also, don't forget, if you do know the principal and the interest, you can use P plus I to get your future value and not use one of these other formulas. Okay? So now it's time to look at some examples and work through some problems. We're going to do that starting at the top of the next page. You will want your calculator handy. As you can tell, there's expressions we will have to evaluate. There's some expressions you can solve. I'll let you read through the before the lectures and make sure you do know how to do those. So our first example, how much interest is earned on an investment of $10,000 for 5 years at 3.25% simple interest. And notice it does tell you simple interest, so that we do know we are using simple interest. So the formula we need to use if we're going to calculate how much interest is earned, since we do have the principal, we know the rate and we know the time, and we're just after the interest earned, we'll use I equals PRT. Interest equals our principal was $10,000 our rate in decimal form, 0.0325, times our time in years, 5 years. Now, since we are dealing with money, we do want to round our answers to 2 decimal places, but we only round the very final answer. Okay. We do need our calculator to calculate this. So, 10,000 times 0.0325 times 5, 1625. No rounding needed. So $1,625 is the interest earned on $10,000 for 5 years at 3.25% simple interest. Okay. Again, note it is telling you simple interest. Number 2, you take out a 90-day loan, $1,500 at 8.5% simple interest. How much do you owe at the end of 90 days? So how much we owe? We owe the principal plus the interest. Okay. Well, if we think back, that is the accumulated amount. So I'll just jump into using the formula for accumulated amount, since we actually know the principal, we know the rate, and we know the time. Remember our value, our formula for accumulated amount with simple interest, A equals P times 1 plus RT. 1 plus RT is in parentheses. We're trying to solve for A. We know the principal was $1,500. We know the rate is 8.5%, so in decimal form, 0.085. We know the time is a 90-day loan. Now remember, for the formula, T is our time in years. So we have a 90-day loan. So the number of years is just, well, we'll write it as a fraction. 90 days, and there's 365 days in 1 year. 90 365ths. 90 days is 90 365ths of a year. Now, I know banker rules tend to use 360 days in a year, but for this math class, for this course, we are using 365 days in 1 year. 52 weeks in 1 year. 12 months in 1 year. So now, to get our answer, we'll just put all this in the calculator and round to 2 decimal places. 1,500 times 1 plus 0.085 times 90 divided by 365. 1531, and rounding to 2 decimal places, 44 cents. 1531.44. So that's how much you owe after 90 days. $31.44 interest in 90 days. Okay? Problem 3. How much would you need to deposit into an account that earns 5.25% simple interest if you want to have $10,000 in 4 years? So we're being asked to solve for the principal. How much do we need to deposit? Right? But we do know the accumulated amount we want. We know the time frame we want it, and we know the interest rate, and it's at simple interest. So again, we're going to use our simple interest formula for accumulated amount, and we're just going to solve for P. Okay, we know the accumulated amount is $10,000. We know we're solving for P. We know the interest rate in decimal form. And we know the time in years is 4 years. Okay. Solving for P, we just divide both sides by what's in parentheses. So 10,000 divided by 1 plus 0.0525 times 4. It's a 5. Okay. Now you noticed I've put this in parentheses because when we put this in our calculator, we want to divide by the entire sum, and to divide by a sum, you must put the sum in parentheses. Okay, so $10,000 divided by 1 plus 0.0525 times 4. Rounding to 2 decimal places, we get $8,264.46. So we'll round that to 2 decimals. $8,264.46. So that's how much you would need to deposit right now, so that in 4 years' time you would have $10,000 if the account earned 5.25% simple interest. Okay? You can also look at it as if you borrow this much money, you'll owe $10,000 in 4 years' time. Another way to look at it, but this asked us how much do we need to deposit, so we are solving for principal. Okay? Moving on to number 4. Slide this up a little. A 4-year bond costs $10,000 and will pay a total of $2,800 in interest over its lifetime. What is the annual interest rate? Okay, so here we know the interest amount, we know the principal. We're after the rate. We also happen to know the time because it's a 4-year bond. Now, we could calculate the accumulated value, which is the principal plus the interest, but we don't need that to actually calculate the interest rate. All we need is interest equals PRT. We know the interest paid over the lifetime is $2,800. We know the principal, the amount invested, costs $10,000. We're being asked to solve for R, and we know it was a 4-year bond, so T is 4. So 2,800 equals 40,000 times R. So we can see R, now remember this is the decimal form, is 2,800 divided by 40,000. You can go ahead and put that in your calculator right now, but as a math person I like to reduce. It's just a habit. So 28 over 400. I know 4 happens to go into both of these numbers, so 7 over 100. And since I have this fraction, I know that my interest rate is 7%. Of course, if you used your calculator, you get 0.07, and I will show you that. 2,800 divided by 40,000. 0.07, which is 7%. Okay. Now, if you tried to approach this from finding the accumulated value using the formula up here, remember A is going to be the principal plus the interest. So you'd start off with 2,800 equals 10,000 times 1 plus R times 4. And you would have to go through that route. Okay? I think this is a little quicker, but both routes should definitely get you there. No problems. Number 5. All right, so this one's a good one, especially since we're in tax season. You are expecting a tax refund of $1,500 in 3 weeks. A tax preparer offers you a $1,500 loan for a fee of $60 to be repaid by your refund check when it arrives in 3 weeks. So what that means is you give them $60 right now, they'll give you the $1,500, and then they'll take your tax refund. The tax refund will go to them. So you get your $1,500 now, but it costs you $60 to get it now. So really, you're only getting $1,440, not the full $1,500. Okay? So we want to think of this $60 fee as interest. And you're asked, what simple interest rate would you be paying on this loan if you accept this deal? So I'll give you a minute to kind of just think of that, see if you think that's a good deal or not, kind of give you a general idea what you think the rate might be, and then we're going to go through and solve it. Or actually, I'll let you pause and take a minute to think about that. All right, so our formula that we're going to use. We know the interest, $60. We know the principal. We know the time. We're trying to find the rate. So again, I'm going to go with interest equals PRT. We could go with the accumulated amount, but we've got to actually calculate that. And the accumulated amount would be $1,560, with the principal being $1,500 if you want to use this formula up here. Again, I want to stick with this one because we do know the interest, we do know the principal, we do know the time. So our interest is $60. Our principal was $1,500. We're trying to solve for the rate. Our time, this is a 3-week loan. So in years, remember T is in years, time in years. 3 weeks is 3 weeks out of 52 weeks in a year, so 3 over 52. Okay. So solving for R, we'll divide both sides by 1,500 to start with. And we're trying to get R by itself, so now we'll multiply both sides by 52 over 3, and I am going to reduce this left-hand side just a little bit and write it as 6 over 150 times 52 over 3 equals R. We'll put that in our calculator, and if you want to reduce more, you can. It does reduce, but we'll put this in our calculator. I'll start multiplying fractions. We multiply across the top. $312. And 150 times 3 is 450. So 312 divided by 450. 0.693 repeating. Okay. With interest rates, you want to actually round the actual interest rate, not the decimal form, but the actual interest rate to 2 places. So 69 point, then we have a bunch of 3s, so that'll just round to 33%. 69.33%. Sounds like a pretty big number for just $60. But if we stop and think about it, you're paying $60 interest for a 3-week loan. That accumulates to $20 a week in interest. 52 weeks in a year, $20 a week. Let's see how much money that would be if we actually took the loan out for a full year. $20 a week, 52 weeks in a year. That would be $1,040 interest paid in 1 year's time. We only borrowed $1,500. 1,040 is more than 2/3 of 1,500, because 2/3 of 1,500 is 1,000. 2/3 is roughly 67%. So our answer does make sense. This is a big interest rate, but hopefully that now makes sense when we look at how much interest we would pay for a full year. And that's what our annual interest rate dictates. Okay? Alright, so hopefully that answer does make sense, even though it is a big number. And I tried to help you out with that. Let me know if you do have questions on why that is such a big number. Okay? A couple more problems here on the last page that we will look at. Numbers 6 and 7. Number 6, we're going to take out a 3-year, $7,000 loan at 8% simple annual interest. The lender is going to charge us a $100 fee. So we're going to think of the fee as additional interest, and then calculate the actual annual interest rate we will pay. So since we're paying more interest with the $100 fee, our answer should be more than 8%. Okay, our final answer should definitely be more than 8%. So to calculate the actual interest rate, we need to know the total amount of interest we paid. So our total interest paid, of course, is our $100 fee plus the interest earned on the loan, or the interest accumulated on the loan. So that's $100 plus, and the interest we earned on the loan is our principal times our rate times our time. So 7,000 times 0.08 times 3 plus $100 fee is $1,780. So that's our total interest paid. That's our total interest paid. So to calculate the interest rate, we know the accumulated amount is the 7,000 plus the interest rate, so I could use that formula, but since I actually know the interest and I know the principal, I'm just going to use that formula of, once again, interest equals principal times rate times time. We know the interest was the $1,780. We know the principal was the 7,000. We know we're solving for R, and it was a 3-year loan, so T is our time in years. So this tells me 1,780 is equal to 21,000 times R, which tells me R is equal to 1,780 divided by 21,000. And again, we're getting this will give us the decimal form of our interest rate, but we actually want to give the interest rate in percentage form. 1,780 divided by 21,000. So we need to write out a few decimals here so we can appropriately round. 0.084769. That should be enough. We want to round our interest rate to 2 decimals. That's the actual percent form, not the decimal form. So 8.4. So we move the decimal 2 places to the right to get it in percent form. So here's where we're looking for our rounding. 6 will round us up to 8.48%. So when you're finding your interest rates, you do want to have the decimal form have quite a few decimals, so that you can round the percent form to the appropriate 2 or 3 decimal places, whichever is requested. I do often ask you to give me 3 decimals for the percentage rate. So having a few decimals out here will help you get your appropriate or properly rounded 3 decimal places for the percent form. All right, number 7, our last example with simple interest. How many days will it take for a sum of $1,400 to earn $40 interest if it is deposited in a bank paying simple interest at the rate of 8% per year? Again, we use a 365-day year, not 360. All right, we're going to be asked to round our answer to the nearest full day. So we can round down because it says to the nearest full day. We do not have to round up. Make sure you do read your directions. Sometimes you are asked to automatically round up. All right, we know our principal, we know our interest, we know our rate. We're after the time. All right, so a couple different ways we can do this, and I'll split our paper up and do it the normal way first. Okay, we know our principal, we know our interest, we know our rate, we're after our time. So again, I'm going to stick with this formula. Our interest is $40. Our principal is $1,400. Our rate in decimal form, and we're solving for T. Okay. So it looks like T is equal to 40 divided by 1400 times 0.08. So again, we're dividing by a product, and we're going to need to put the entire product in a set of parentheses for this to work right. 40 divided by 1400 times 0.08. 0.35714. Okay, so 0.35714 years. Now the question asked how many days. Okay, remember T is always in years, so this is in years. So we have to do some converting. Now if you've had any chemistry, you do a lot of converting. I know most of you have not had chemistry. So we've got to take this number of years and to be honest, we shouldn't do any rounding. We should keep all the decimals that we can. So I'm copying them down from the calculator. Years. And then we'll convert. We want to get rid of years, so it goes on the bottom, because years over here is on the top. This is understood to be over 1. So that makes the years unit cancel. And we want the answer to be in days. Well, there's 365 days in 1 year. Our year unit now cancels, and our answer will be in days. So we take the answer from our calculator screen and multiply it by 365. And we round this to the nearest whole number of days. Round your answer to the nearest full day being a whole number. So to the nearest day is 130 days. Now, it will take more than 130 days. 130.357 days. So we'll go with 130 days. Okay. An alternative way to do this problem, again, is to start with the same formula. Interest equals our principal times our rate. But since our time is in years and we want our answer to be in days, we'll go ahead and convert that. Number of days over 365. Number of days, D, and we'll just solve for D. D is number of days. So 40 equals 1400 times 0.08 times D over 365. Now, 40 divided by 1400 times 0.08 equals D over 365. Solving for D, we just need to multiply both sides by 365, which if we think about it, 40 divided by 14,000 times 0.08 is what we did here and got this decimal, and we took this decimal and multiplied it by 365. So we're doing the exact same process. We just set the work up a little bit better in the formula. Since we knew our answer needed to be in days, we kind of converted the T variable, which is T in years, to days. Number of days over 365. Okay. So we do indeed get the same answer, but just to show you with the calculator, 40 times 365 divided by 1400 times 0.08. We do get that same number of days, 130.357. Okay, I'll make sure that's in the screen. All right, so we'll write down 130 days. Same answer, just two different ways to set it up. Remember, time is always in years. And so if we went 720 days, 720 over 365 is close to 2 years. So that's okay. It's just we wanted our answer to be in days, so we wrote it this way. Okay? All right. If you wanted your answer to be in weeks, you could put W over 52. If you want it to be in hours, H over how many hours are in a year. And you can do that that transformation, okay, or that you can do that calculation to see how many hours are in a year. Okay. All right, that is the end of simple interest. The next video will look at compound interest. Let me know if you have any questions about these problems. We will be working on some similar to these in class.